Alright, I think I'm just going to briefly go over with you guys in this problem, and this is 2018 AMC 10 Test B, question 13. I'm just going to briefly run through this problem with you guys, alright? So if you're having trouble, just run through the video back, okay? And so this is how you do the problem, okay? So it says, how many of the first 2018 numbers in the sequence 101, 1001, 10001, 100001, and so on are divisible by 101, right? So when I look at the word sequence over here, I want to look at patterns, right? That's the key. Is there a pattern between each number divisible by 101? Is there a pattern between that? All right. Is there a pattern in the zeros? And we see that there is. All right. So the terms in this sequence are just we increase a zero in each term. Okay. And so how many are divisible by 101? All right, so let's try to do this. So we know the first one is divisible by 101, right? So we're going to write term 1 is divisible by 101 right here. We know that this one is not divisible by 101, right? That's an obvious one right there. We know that, is this one divisible by 101 right here, okay? So let's try that out. So term 3. Is this divisible by 101? So we're going to go 9. 911 is not a factor of 101, so we know that term 3 is not a divisible by 101. It's term 4 divisible by 101. So that we have 9, 909, 91, we have a 0, 9, 1, 1. 11 is not a factor of 101, so we know that this fourth one is not, okay? So let's try with 5 zeros now. I'm feeling good about this one. So we have 9 right here, 909. And we have right here that 101, yes, it is indeed a factor of 101. Alright, so we know that terms 1 and 5 are divisible by 101, alright? And so, so we have our first two right here. And what's the difference between 5 and 1? Alright, this is the first thing that popped up in my head. So the difference between 1 and 5 is 4, right? So maybe, just maybe, there might be a little pattern here where if we increase the sequence by 4 zeros each time after 1, alright, so then it might be divisible by 101, alright? So I tried dividing it by 9 as well, with 9 zeros, 101 by 9 zeros, and that was a factor too. I did it with 13 zeros as well, and the 1000 with 13 zeros is also divisible by 101. Alright, so we see it. So what I saw each time I was just looking for patterns, and this was a pattern. Alright, so after I found this pattern, I tried to set up an equation for it, to find how many are divisible by 101. And so we know that there are 2018 numbers in this whole entire sequence, so we could just keep going 1, 5, 9, 13 all the way to 2018, but that would take too long. Alright, so let's try to figure out a function where we can find all the numbers in the sequence, right? 1, 5, 9, 13 all the way to 2018. Alright, so how do we do this? Well, we're starting with 1, we're increasing by 4. Let me refer back to my paper. Okay, so we're starting at, come on, try to find it, Andrew, where is it? You can skip ahead of the video, try to find this. All right. Oh, here it is. So to find all the numbers of, so it's gonna be, we're starting at 1, and then the difference is 4, right? So 4 plus n minus 1. All right, because 1 is the first term of the sequence. All right, and so um here's how to do it. All right, so n is the first term of the sequence, and we're gonna find all the way up to 2018. All right, all the numbers up to 2018. All right, so let's do it. So let's first distribute 4 to these. So 4n minus 4 plus 1. All right, because this 1 right here is equal to 2018. We know that negative 4 plus 1 is negative 3. Add 3 on both sides, so we have 4n is equal to 2021. If you divide 2021 divided by 4, all right, I already did that, but you can do it on your paper. That is equal to 505.25. All right, and so this 0.25 is kind of a problem for us here. All right, how would we do that? All right, well, oh whoops, I accidentally opened up Skype. Well, all right, yeah. So that's 505 point. That 0.25 is kind of a problem for us, all right. And we don't like 0.25. So what are we gonna do about it, all right? Well, it's saying how many of the first 2018 numbers in the sequence are divisible by this, all right? And so we can't have 0.25 of a number, right? And because 0.25 number that'd be over 2018 numbers, okay? So we just stop right there and have our answer 505, okay? And there we go. That is how you solve the problem. All right. So the first thing you really want to remember when you see sequence, remember to try to find a pattern between each of the numbers. All right. Patterns are the key to solving these sequence problems.